Pharmacology students, this is Dr. Herndon again. Today I'm going to be talking about IV fluid calculations. As a veterinary technician, it's often up to you to both place an IV catheter and a fluid administration set and hook a patient up to fluids and possibly calculate a fluid drip rate or maybe calculate a constant rate infusion. And then it'll be up to you to maintain that patient's catheter and make sure that the patient is receiving the proper amount of IV fluids or medications. So we'll be talking about formulas that we can use to calculate the amount of a medication or the amount of a fluid that's going to be administered either continuously or over a defined period of time. In order to do this, we have a selection of various drip sets that we can use that are calibrated to deliver a precise number of drops per mil. If you look in this picture and you see this little drop coming out, the number of drops per mil differs based on the type of drip set. The one that we most commonly use is called the standard macro drip set, and that delivers 15 drops per mil. This is called the drop factor, and we use the drop factor in our IV fluid calculations. You will also see what's called a mini drip or micro drip set used. This delivers smaller drops, so there's more drops per mil, 60 drops per mil. There are other sizes of IV drip sets that give you 10 drops per mil and 20 drops per mil. So you need to know what you're working with in order to calculate fluid drip rates. Let's look at the formula here. This is a basic fluid rate formula. So fluid rate, or commonly called a drip rate. So this will give you the number of drops per minute that you need to administer to a patient given a particular volume of fluid infusion and a particular defined time. And you also need to know the drop factor of the fluid administration set that you're using. So the fluid rate in this case, is going to be drops per minute. We need to know the volume of the infusion in mils. We also need to know the time period over which this patient is going to receive the fluids in minutes. Now this is important right here. It has to be in minutes. And then we need to know the drop factor. I'm going to do DF for drop factor, which is going to be in drops per mil. Now the answer is going to be in drops per minute, but we can always convert this to drops per second after we're done. All right, let's try a problem. I've given you the fluid drip rate formula down at the bottom of this page, and up at the top is a problem. It reads, give 480 mils of lactated ringer solution over a 4-hour period using a standard 15 drop per mil administration set. What is the fluid drip rate? So we're looking for the fluid rate or the fluid drip rate. So the first thing I'd like to do in these sort of problems is find all my values. So let's start with the volume. What's our volume in mils? Our volume in mils is 480 mils. Next, I'll look for the time. How long is this infusion going to be administered? Well, in the problem, it reads 4 hours. So the time is 4 hours, but we need to get that in minutes in order to plug it in. So that's an easy conversion because I know that 1 hour is equal to 60 minutes, and I can easily do this calculation. That equals 240 minutes. So that's our time. And the third factor down here is the drop factor, which is given in the problem. We're using a standard 15 drop per mil administration set. So now it's a matter of plugging in the values. So our fluid drip rate, which I'm going to write as R, equals the volume of infusion, which is 480 mils, divided by the time of infusion, which is 240 minutes, multiplied times the drop factor, which is 15 drops per mil. I can look at this real fast and say, oh, I'll be able to cross out mils, and I can see that my units are going to be in drops per minute. So I'm going to do the calculations here. 480 divided by 240 times 15 equals 30 drops per minute. Now, this is great if you have the time to stand and adjust a fluid rate over the course of a minute. Doesn't seem like a long time, but if you're counting 30 drops and then you have to readjust a couple times, that's going to take you a while, and you have something else to do, no doubt. So we usually convert a fluid rate in drops per minute to either drops per second or drops per 2 seconds or 5 seconds or something that gives us a whole number. So this is easy enough to do. If I have 30 drops per minute, I can easily convert to seconds. 1 minute is equivalent to 60 seconds. I can see the minutes cancel out. 30 divided by 60 equals a half. So 0.5 drops per second. Now, these administration sets aren't meant for you to count a half a drop. So what we're going to do is to multiply it times something that's going to give us a whole number. And this is easy because 0.5 times 2 equals 1. But we have to multiply both top and bottom by 2 so that we're multiplying by 1, right? So 0.5 times 2 equals 1. And on the bottom, 2 times 1 second equals 2 seconds. So this is a much easier thing to work with here. 1 drop every 2 seconds. You can easily adjust and count in 2 seconds and adjust your drip rate and then go on and do something else. Okay, now here's an example for you to try. Go ahead and pause the video, try this problem, and when you're finished, go ahead and start the video again and I'll go over the answer. Alright, let's find all our values for this problem. What drip rate would you use to deliver 120 mils, that's our volume, of 0.9% sodium chloride? We don't need to use this percentage, this just tells us what type of solution it is. Over a 2-hour period, so we know the time is 2 hours, which comes out to 120 minutes, using a micro drip or 60 drops per mil administration set. Alright, so let's set it up. Our drip rate equals our volume divided by the time in minutes times our drop factor. I'm going to cancel out our mils. I can cancel out 120 over 120. That equals 1. So it's 60 times 1. This comes out to 60 drops per minute. Okay, 60 drops per minute. This is easy to convert to drops per second. 60 drops per minute. Remember, 1 minute is equivalent to 60 seconds. Minutes cancel. 60 divided by 60 equals 1 drop per second. Let's go over the next type of calculation you might run across. These are called constant rate infusions, or CRIs, and I'm going to tell you that these are universally hated by both veterinarians and veterinary technicians alike. However, I believe it's because most of the time the technicians or the vets don't have a really good formula on hand to use. That being said, nowadays there's different types of drug calculators or spreadsheets or whatever that you simply plug numbers in and it'll do the calculations for you. However, I do think it's important for you to have at least one tool to be able to use if you're asked to calculate a constant rate infusion. So what we're talking about here are some sort of medications that are given via an IV infusion. And typically they're drugs that either have a really short half-life or they have to be given in very, very small amounts. And they're often given along with fluids at a constant rate over a particular period of time. Sometimes we'll give constant rate infusions of, let's say, an analgesic like fentanyl or something like that during a especially painful surgery. Maybe we have to control an arrhythmia in a patient, so we're giving lidocaine or something like that in an IV infusion. You will see when working with constant rate infusions that the actual dosage rate of a constant rate infusion, it looks sort of similar to a drug dosage rate. It's typically in micrograms per kilogram per minute. So if you look carefully at this, here's the looking like a dosage rate part here, micrograms per kilogram, except it's you'll usually see it in micrograms because we're working with much smaller amounts. So we're working with a small amount of a drug in micrograms per kilogram of body weight. But the only difference here is that it's over a course of a period of time. So I added time in. So micrograms per kilogram per minute is going to be the dosage rate of the constant rate infusion. Now, here I've given you a formula. There are many ways to do CRI calculations. I think for your purposes, if you have one formula or like one tool that you can use, you're going to be better off. The problem is having to memorize it. Well, I've put this formula on our formula sheet for you to use when you need it. It may be something that you want to keep somewhere and make sure you know what all these letters mean. So this is important. M equals D times W times V over R times this weird number. All right, what are these letters? M is the number of milligrams of drug to add to a base solution. D is the dosage rate of the drug that's going to be given at the constant rate infusion. And again, I mentioned that the dosage rate for these CRI drugs is usually in micrograms per kg per minute. W, as before, is the body weight of the patient in kilograms. And V is the volume in mils of the base solution. So the base solution could be like a small bag of IV fluids or lactated ringer solution or something like that. And R is the rate of delivery in mils per hour. I'm not going to go into detail now, but we have automated infusion pumps, which make it much more easy to deliver constant rate infusion drugs, where you can set this up and you can plug in the mils per hour. But this is how fast we're going to give this infusion. And down here, this is a conversion factor that's key to this whole formula right here. Now, let's try to do a constant rate infusion problem. I put the problem on the top. Over on the left-hand side are the different values that we need to figure out. And over on the right-hand side is the formula we're going to use and an explanation of all the different letters. All right, let me read the problem first. A 44-pound dog with CHF, that means congestive heart failure, is ordered to receive a dopamine constant rate infusion at 5 micrograms per kilogram per minute. You will add 200 milligrams of dopamine to a 1 liter bag of LRS solution, that's lactated ringer solution. This here is just telling you what your concentration is of that solution you just made up. At what rate in mils per hour will you administer this solution to deliver the correct dosage? So the first thing we're going to do here is to figure out what all our values are. And I'm going to use this down here to help me remember what my letters mean. Let's start at the beginning. We have a patient that's 44 pounds. We need weight in kilograms. I did the calculation for you. 44 pounds divided by 2.2 equals 20 kilograms. The drug that's going to be administered as a CRI is dopamine at a rate of 5 micrograms per kilogram per minute. So that is the D, the dosage rate of the drug in micrograms per kilogram per minute. So D equals 5 micrograms per kilogram per minute. Don't ever leave off your units when you're writing out formulas. That gets you in trouble. Then you'll forget what you end up with when you get your answer. You will add 200 mg of dopamine. Well, that's our M right here, the number of milligrams of drug to add to the base solution. All right, we're going to put that up here, 200 milligrams of dopamine to a 1 liter bag of lactated ringer solution. Here's this, V, 1 liter. Let's just change that to milliliters. 1,000 mils. At what rate in mils per hour will you administer this solution to deliver the correct dosage? So R is going to be our rate. So this is what we don't know. This is what we want to know right here. R is the rate of delivery of your drug in mils per hour. So we can plug in all our numbers here. The interesting thing here is that we are solving for R. So if we want to rework our formula, we can look at it this way. We're going to move this up and we're going to move this M down here. We're going to have R equals D times W times V divided by M times 16.67. I just moved things around a little bit. It's the same formula. So what we're going to do is plug in all our numbers into this formula. So I'm going to go to another page and do that so I have more space to work. Okay, let's go ahead and plug in all our values in our constant rate infusion here. So we're looking for R in this case. R is the rate of administration of our drug that we're giving. R equals D, which is our drug dosage rate, which is 5 micrograms per kilogram per minute. W is the weight of the patient, 20 kilograms. V is the volume, or the total amount of solution we're putting our drug into, which is 1,000 mils. M is the amount of dopamine that we are adding to the fluid, which was 200 milligrams. And 16.67 is our conversion factor. Take a look at the units here, see if you can cancel anything out. I can see I can cancel out kilograms here, minutes and mils stays. I should be able to cancel out my weights, but one of the problems is that the units are different, so we're going to have to get them the same. I think what I'm going to do is convert 200 milligrams to micrograms, so then we can cancel out our micrograms. So I know that if I move my decimal point 3 places to the right, so our value instead of 200 milligrams comes out to be 200,000 micrograms. So we're going to use this in our formula instead. I'm going to move this up into my formula right here. Okay, now let's do the math. Well, we can cancel out micrograms. Now let's do the math. So 5 times 20 times 1,000 divided by 200,000 and 16.67 equals 0.03, and our answer is going to be in mils per minute. Now, if we needed to convert from mils to minute to mils per hour, let's say our infusion pump is setting as in mils per hour, That's easily changed. 0.03 mils per minute. I know that 60 minutes is equivalent to 1 hour. Cancel out our units. 0.03 times 60 equals 1.8 mils per hour. Okay, I've spoken for too long in this video, so instead of giving you a practice problem in the video, I think you should move on to the IV fluids quiz on Canvas. There are a number of different fluid rate and CRI problems, and we will go over that in class.